here we will see cover. Cover is what? Cover is actually the space occupied by a fabric. The yarn spacing I talk about the warp and weft spacing. Suppose, for example, if I talk about these are warp yarns and these are weft yarns. So the occupied what the thing the fabric that is occupied. So that is calculated by the cover thing. The amount of space occupied in a fabric is known as cover. If the cover is very high, then the fabric we can say that the fabric is highly dense. The spacing between the yarns is very less. Suppose there is yarn to yarn spacing. If I talk about it, the yarn spacing is very less, then the fabric cover is very high. And if the yarn spacing is very high, then the fabric is cover means less dense. So if I talk about cover C1 warp cover, it is a fractional cover, so D1 distance 1 upon spacing in the first fabric. And if I talk about it is fractional cover for warp, and if I talk about fractional cover for weft, then it is D2 upon S2, it is total. And if I talk about total cover, C is equal to C1 plus C2 minus C1 C2. 1 upon spacing is actually n, means the if I talk about ends per inch per picks per inch, this is the thing that you can solve easily. So if for this, if I talk about some of the numericals for this cover questions. So uh, you have understood the basics of cover, and this cover is very important. If I talk about the loom geometry concept and fabric geometry concept, because uh, in every end product of the fabric you have to see the cover, and in the gate questions particularly this cover is mentioned. Ki cover is suppose the cover is 60%, that means the total fabric occupies 60% and the rest is space is unoccupied. We have talked about I guess porosity and yarn porosity and packing fraction. Packing fraction was on similar line, means packing fraction what we have read ki packing fraction is the space occupied in a yarn. So this is all these things that we have already discussed. Now coming to the next thing, one thing is cover factor. What cover factor is? Cover factor is represented by k. It is cover factor, it is equal to 28 into c. Suppose there are two cover factors that is given, k1 and k2. So the net cover factor you can talk about k is equal to k1 plus k2 minus k1 k2 upon 28. It is the net cover factor if I talk about. Now during the manufacturing of the fabric, there are shedding processes, picking processes. We have already discussed how the pick is inserted. So there are 2 3 shaft. In the picking process, picking means when the weft yarn is picked and is inserted on the warp yarn, the process between them is known as pricking. So there are 3 shafts that are associated: crankshaft, crankshaft, bottom shaft, and tappet shaft. If I talk about crankshaft, then crankshaft is, suppose the cycle is n rpm. The fabric is moving with n rpm. So in a bottom shaft, so these are 3 different types of. So the rpm in the bottom shaft would be half of that of crankshaft, and in the tappet shaft it would be n by x. X is number of tappets. This we will see with the help of example, see how it would be solved. It will depend on the number of ends in a repeat unit. For example, if I say about 5 by 3 weave structure, the weave structure 5 by 3 means 5 up 5 up weave and 1 down weave, 3 down weaves. Sorry. So this is how the structure will look out. So if we calculate, n is how much total? Total n is 5 plus 3, 5 up and 3 down. The 5 on the barb and then on a plane weave I am talking about. Then 5 plus 3, it is 8. So it is the r n is 8. This ratio is for crankshaft. In the gate question, what is asked is ratio of crankshaft to the bottom shaft to the tappet shaft. You have to calculate. So in case of here, what you will see, so n is equal to 8, n by 2 is equal to, so total we will calculate, the RPM would be 8, and so we will calculate it accordingly. I will give you one example, then you can associate with differently. The ratio of the tappet shaft would be n by 8. Of course, it is n by 2 for bottom shaft, and it is n by 8 for tappet shaft. Actually, it is x is not n, it is x. X is the number of repeats. So n would be given to you. Now, suppose, for example, if I talk about crankshaft rotation, it is crankshaft RPM is given as 300. You have to calculate the speed of the bottom shaft in radian per second. The speed of bottom shaft in radian per second. How we will calculate the speed of the crankshaft as 300. So for bottom shaft would be 300 by 2. It is 150 per minute. And for minute, conversion into radian. So for radian, you know that this entire is 2 pi radian. 2 pi radian means 360 degree in fact. So first we have to convert this into seconds, and this seconds we have to convert because it is radian per second. So we have to convert this into seconds, and now into radian. For conversion into radian, we have to multiply it by 2 pi. So we will multiply by 2 pi for conversion into radian. As radian per second, you can find the answer. It would be somewhat 15.7 radian per second. This is how you will calculate. Now suppose write the next gate question that is asked. The bottom shaft of a shuttle loom in a 2 by 112 is rotating at 2 by 112 weave is given. Rotating at 90 RPM. The speed of the camshaft means tappet shaft. You have to find it out in RPM is. So the 90 is for what? It is the RPM of the bottom shaft. Bottom shaft of a shuttle loom. Bottom shaft. So bottom shaft is actually is n upon 2. It is given as 90. So n is 180 RPM. And 180 RPM is for what? 180 RPM is of the crankshaft. So the weave is given as 2 by 1. So total x is equal to 2 plus 1, that is equal to 3. Since you have to calculate the speed of the tappet shaft. Tappet shaft. For tappet shaft, you can calculate upon n by x. N by x means 180 upon x is 3. So this is what 60 RPM is the answer. I think it is clear. Now the next gate question, it is also gate question. Shuttle loom is running at 240 ppm, 240 picks per minute. The angular velocity of the bottom shaft in radian per second is n pi. The angular velocity is given of the bottom shaft. Bottom shaft is given as n pi. So how you will calculate the value of the n, you have to calculate, since 240 pics per minute it is given, so you can calculate pics per second. It is 4 per second. 4 per second. The shuttle loom is running at this speed. So this is the speed of crankshaft. The question it says, and then it says that the angular velocity of the bottom shaft. So the for bottom shaft it would be how much? 4 by 2 per second. 2 per second. And since it is in radian per second, you have to calculate. So I told you to multiply by 2 pi for conversion into radian. So it is 4 pi radian per second. 4 pi radian per second. Then, and this is the speed of the bottom shaft. And it is given in the question that the speed is n pi. So equating n pi with 4 pi, so we can get n is equal to 4. This is the type of the questions that are asked in the gate examination. So n is 4. It is a recent gate paper. Uh, Now, one more question for the things that we have discussed till now is, suppose warp count is given as 25 ticks, EPCM is given as 25, warp crimp is 6%, weft count is 32 ticks, EPCM picks per centimeter is 15, weft crimp is 8%. Then warp GSM you have to find the total GSM of the fabric. So warp GSM we can calculate. How we will calculate the warp GSM? 25 text 25 per 1000 gram, gram per 1000 meter. It is 25 EPCM ends per centimeter. Centimeter for conversion into ends per centimeter. For conversion of centimeter into meter, we have to multiply this by 100, and this is 6%. So 1 plus 6 by 100. 1 plus 6 upon 100. This is how we will calculate. So if you will calculate, then it will come out to be 66.25 gram per meter square. And similarly for the weft, you have to calculate that the GSM 32 gram upon 1000 meter into 15 into 100 upon meter into 8% is be 1.08. It would come out to be 51.84 gram per meter square. Total GSM would be how much? Total GSM would be addition of both these things, then it will come out to be 118.0% square. So this is how we will do with these types of picking questions in the